Yeah, the white widow is a real spider, and its name isn't a lie either. It might look nothing like the black widow, but it has a powerful neurotoxic venom and an hourglass mark of its own, only pale white instead of the vibrant red we're used to. Native to parts of the Middle East and Northern Africa, the reason you probably have never heard of it is it's one of the rarest widow spiders on Earth. Because it's not just the black widow and the white widow. There's tons of other different colors across the nearly 35 different species of widows that exist in the world. And much like an iceberg, what we see on the surface is only a fraction of the insane biology these spiders actually hide. As we dive deeper into the world of widows, we're gonna see that they are actually rich in biological secrets. It's not just the venom and hourglass mark that make widow spiders widow spiders. In this video, we'll probably change how you see not just widows, but all spiders for good. So if this is a widow spider, this is a widow spider, this is a widow spider, but this is not a widow spider, it kind of begs the question, what is a widow in the first place? The short answer is any spider in the genus Latrodectus is a widow spider. Latrodectus is a combination of Greek and Latin words, meaning biting thief. Probably because these spiders wind up in your cupboards or in little forgotten tucked away corners of your house where you probably don't want them, and are most famously known for their incredibly painful bite. This genus is most famous for the females of the genus, which are larger, round, often black spiders that typically have that bright, vibrant hourglass right on the underside of their abdomen. And they get the nickname widows from their ever so infamous habit of eating the males during mating, a process we call sexual cannibalism. That's a phrase I never thought I would use. Though despite their cannibalistic reputation, most species of widows are not eating the males 100% of the time. It actually happens a lot less often than you'd think. But a few scientists observed it a few times and the nickname stuck, so here we are. All Latrodectus, whether they have super crazy bright colors, geometric patterns on a pale body, or the classic jet black we usually think of, they are these round spiders with long, spindly legs that tend to live in messy, disorganized webs, which is actually characteristic of the family these spiders belong to. The widow spiders belong to a much larger group of spiders, one of the most successful groups in the world, the Therodiidae. These spiders are better known as the cobweb spiders, and these spiders exist on every continent except Antarctica, so I guarantee you there's probably a cobweb spider in your house while you watch this video right now. They get their name from the messy, disorganized, tangled webs that they tend to build in tucked away corners, oftentimes inside cupboards, behind your toilet, in dusty crevices in your garage, and forgotten cardboard boxes in your attic. The reason they turn up in these places is because they are most similar to the microhabitats that cobweb spiders would actually live in out in the wilderness. They prefer to live inside the bark of trees, or inside hollow logs, underneath rocks, sometimes rock crevices inside or near caves. Some species live inside of plants, and they're easily identifiable with that tangled, disheveled looking web. But the most well-known thing about the widow spiders has to be their bite. And the bite of these spiders is a pretty terrifying thing, probably scarier than you'd think.
I don't care what you say, these spiders... Ow! What happened? Bit me. Oh no.
Tons of people are bitten by widow spiders every single year, like numbering in the thousands. So there's a good chance you know somebody or at least have heard of someone who's been bitten by a black widow or one of their relatives. And the story is pretty similar. It is one of the worst things you can experience. It feels like a really bad, really painful flu, complete with muscle spasms, horrible body aches, and just this radiating pain that courses through your entire body that no over-the-counter medication will even come close to touching. Headaches, back pain, nausea, the works. It is wildly unpleasant to be bitten by one of these spiders. And it's fairly common knowledge that this pain is due to the spider's venom. Now, most spiders are venomous, and they're using that venom to kill their insect prey. But most spiders are not normally thought of as venomous because their bites don't really do anything to people. There's only a select few spiders whose venom is toxic enough to actually affect much larger animals like us humans. Even the largest spiders are still pretty small, so it takes a pretty powerful toxin for something this small to actually affect us. And it turns out that widows are actually wildly venomous. Their venom is among the most potent of any arachnid in the world. We measure venom potency in terms of lethal doses, where the smaller the number, the more powerful the venom, because it takes less of that venom to kill you. While many species of widow spider are pretty understudied, the ones we have categorized range from scores of like 2 all the way down to 0.2, which puts them in the range of venomous snakes like rattlesnakes, all the way down to things like cobras. So it's kind of no surprise that widows are often thought of as deadly spiders. Their venom is up there with the venoms of many deadly snakes. And what makes their venom so powerful is it's in a class of toxins known as neurotoxins that attack the nervous system. And the mechanism of this venom is really scary, which we're going to talk about a little bit later in this video. What I want to talk about here is actually why bites occur in the first place. It's kind of weird when you think about it. Their venom is powerful enough to hurt us, but we're not food to these spiders, so why are they biting us? Why would they want to use that venom to harm us if we're not food? And the truth is that many of these spiders actually don't. I have handled many different species of widow spider and many different individuals of those species of widow spider. And for the vast majority of them, I have had 0 issues. Widow spiders are actually quite shy. They're very secretive, rather polite spiders that prefer to keep to themselves. They pretty much only bite when they feel that they need to defend themselves, and usually, only as an absolute last resort. The widow spiders actually have a whole move set of other things they will do first before they resort to violence. Most commonly, they're gonna just scurry away. You know, most of their webs are in tucked away crevices of the habitat, so there tend to be even more tucked away parts of their webs that are nearly impossible to get to. These spiders tend to actually build little funnel-like retreats deep in the plants they call home or the rock crevices they're living in, areas that they can actually tuck away into if they are confronted by a potential predator. If they are cornered, they'll actually throw web at their attacker. They can use these viscous, sticky globs of silk that they can actually spray with their back legs, and it's super sticky and oily and uncomfortable to have on your hands. Given that widows have among the strongest silk of any spider, that defensive silk can actually be pretty hindering of your movement if you're a small mammal trying to root around and eat the spider. And if that's like on your face and in your eyes, the discomfort alone of having that silk all over you is usually enough to get you to back off and keep the spider from having to resort to violence. But what's crazy enough is for most widow species, their coloration alone is actually their biggest defense. You know, that jet black body with a bright red hourglass is not giving them camouflage in any natural habitat. Many species of widows also have crazy vibrant patternings on the back of their abdomen too, and this bright coloration serves as an aposematic warning that these spiders are highly venomous, which is usually enough to make most things simply leave them alone. But if that hourglass is meant to scare things off, why is it that for the vast majority of widow species, it's on the underside and not somewhere more visible like the back? To answer that question, we actually need to look at the one widow spider that sometimes lacks an hourglass entirely. One of my personal favorites, the red widow. These guys live in the most open habitat of all widow spiders. The fly-through zones in palmetto scrub habitats in central and southern Florida. And their ecology is almost more like that of an orb-weaving spider than your typical widow spider. Rather than hunting for ground-dwelling insects in tucked-away nooks of the habitat, they're building rather large webs in open fly-through zones to snag flying insects out of the air. These spiders can be encountered from all 3 dimensions. Because they're not restricted to just one little corner on the ground, but pretty much a waist-high, open-air environment, they've evolved to have bright coloration over their entire body. And bright coloration over their entire body defeats the need to have one vibrant hourglass on the bottom of their abdomen. Now, some populations do still have hourglass marks, but it's often small, reduced. You might get some populations that only have a triangle, and there are some where it's lacking entirely. But with scarlet legs and those crazy red spots all over the back of their abdomen, they really don't need it to advertise that they're highly venomous to make most predators leave them alone. The ecology of these spiders actually shapes the coloration that they have. Most widow spiders, even rare and obscure species like the Chilean redback, for example, do tend to hide more in crevices. Instead of hunting flying insects, most of them are hunting little things like isopods, ants, and beetles. They're hunting ground-crawling arthropods underneath rocks, inside hollow logs or the buttresses of trees, and they serve as a top-down control on many of these small terrestrial arthropods. You know, we think of widows as these highly venomous spiders that have a horribly painful bite, but they actually do play a role in the ecosystem. They are maintaining the balance of the subterranean world by regulating populations of many of these small invertebrates that call that top layer of soil home. But even with how charismatic and venomous these spiders are, they are still pretty small animals. And spiders in general, even the largest tarantulas, are food for other things. We forget that the ecosystem doesn't exist in just a little bubble where the spider is a predator of little insects. There's lots of things that would love to eat the spider, and things that eat the spiders, and so on. So in order to survive, the widows kind of need some manner of defending themselves. Let's take a look at the body plan of this spider again. They have these long, spindly legs, tiny little cephalothorax, and this huge abdomen that makes up most of their body weight. So if you are an animal that lives in a web and most of your weight is in your abdomen, you're probably not sitting on top of the web. You're hanging underneath. For their size, these spiders are very heavy-bodied, so they often hang upside down in their webs. And since they're living in these little crevices close to the ground, the way that they are most likely going to encounter their predators is when it is rooting around in the ground where they've built their web. This is true of common black widows in the US, this is true of brown widows across the world, it's true of many of the obscure rainforest and desert species in South America, and it's true of the infamous redback in Australia. In the habitats these spiders are living, it is actually more often that their underside is going to be exposed to the outside world more than it's going to be their back. And that is exactly why, almost universal across the genus Latrodectus, the hourglass mark is on the underside and not the back of the spider. But that starts to beg the question, these are secretive spiders living in crevices and tucked away spots close to the ground, and yet there are dozens of species throughout the world. How did all of the different widows get all over the place to the point where the black widow has become a cultural symbol of spiders? Surely they can't fly, right? Turns out they kind of can. See, when they first hatch, many spiders have this really unusual ability. They can kind of technically fly, but they're not flying in the way that most things do. They're not like flapping their legs as wings and zipping around. They're shooting out these little parachutes of silk that can actually ride static charges in the air and provide lift. Since they're so tiny and so light, they can pretty much just ride air currents wherever. Now, generally, this is used for local dispersal. So, they might be going a few miles away from where they hatched. So this doesn't fully explain how they got established on every continent but Antarctica. But if we look at the evolutionary history of widows and of Theridiidae as a whole, it kind of can explain how they got everywhere. See, Theridiidae has its origins in the Cretaceous period, over 65 million years ago. And the continents didn't look the way they look now 65 million years ago. They looked more like this. And since the distance between South America and Africa was not thousands and thousands of miles, you theoretically could actually disperse between the two continents. Much like humans, it's thought that Latrodectus originated in Africa, and it actually split into two different lineages. There's the Geometricus clade, home to the brown widow, and Latrodectus rhodesiensis, the much paler mottled widow species. And then the Latrodectus mactans clade, which are the typical black widows that also include some of the fancier colored ones like the red and white widows. After this initial dispersal out of Africa, we got 35 known species as of the making of this video, but considering some of them were discovered as recently as 2021, by the time you're seeing this, that number could be even higher. And they cover literally everywhere. In North America, we have Latrodectus bishopi, the red widow, Latrodectus hesperus, the western black widow, Latrodectus mactans, the southern black widow, Latrodectus occidentalis, the Mexican black widow, and Latrodectus variolus, the northern black widow, with some overlap in the Caribbean, which is technically on the North American plate, of Latrodectus curacaviensis that is more associated with South America. Also in South America, we have a ton of crazy endemics. Things like Latrodectus antheratus, Latrodectus apicalis, which is endemic to the Galapagos Islands, Latrodectus corallinus, Latrodectus diageta, Latrodectus garbe, Latrodectus hurtadoi, Latrodectus mirabilis, Latrodectus cortis, Latrodectus thoracicus, the Chilean redback, which is honestly not documented often online, and Latrodectus variegatus. Europe is tied for having the least widow diversity, so that's either a good thing if you're not a spider person or a bad thing if you are a spider person, with Latrodectus lilianae and Latrodectus tridecimguttatus, the Mediterranean black widow. In my opinion, the Latrodectus from Asia are probably among the coolest, but I'm kind of biased because they have the white widow. You've got Latrodectus dali, Latrodectus elegans, Latrodectus erythromelis, Latrodectus histris, which is like this crazy desert endemic that like nobody has ever filmed, Latrodectus pallidus, the white widow we've mentioned several times throughout this video, and Latrodectus revivensis. Africa has Latrodectus cinctus, Latrodectus geometricus, the brown widow, which is actually invasive throughout tons of countries in the world now, Latrodectus indistinctus, Latrodectus caruensis, Latrodectus menivodi, Latrodectus obscurior, Latrodectus renivulvatus, Latrodectus rhodesiensis, and Latrodectus umbuquanae. The last two are some of the most iconic. Over in Oceania, home to Australia and New Zealand, we have Latrodectus hesaltai, the redback spider, and Latrodectus katipo from New Zealand, the katipo. These guys are everywhere, have literally conquered the globe. And the reason they've done so is because they are experts at chemical warfare. Remember how I mentioned that we'd get into the venom a little bit later? Well, now is later, and the venom of the widow spiders is actually insane. When we think of venom, I think our brains generally jump to like a toxic fluid that just destroys whatever it touches, kind of like an acid or something. But venoms are actually these cocktails of different proteins, and the proteins all basically do things that interfere with the bodies of whatever was bitten. We classify these venom proteins in the widow venom as latrotoxins, named after the genus Latrodectus. And there's actually quite a few of them. You have a bunch of insect-specific toxins, but they're called latroinsectotoxins. You have one crustacean-specific toxin, which we call alpha-latrocrustatoxin. And then the most important one that is actually affecting us, alpha-latrotoxin. Now, you'll recall earlier that I said that the widow venom toxicity range is usually from like 0.2 to 2. So in like the cobra to rattlesnake range. But alpha-latrotoxin, like pure alpha-latrotoxin, has an LD50 score of 0.0004. So that toxin on its own is up there with some of the most potent toxins in the world. Things like cone snail venom, golden arrow frog poison, and even Brazilian wandering spider venom. Like, if widow venom was just alpha-latrotoxin, they would actually be the most venomous spiders in the world. Their venom is a lot more than just alpha-latrotoxin, so we can't classify them on one ingredient, but that active ingredient is really frickin' powerful. And to understand how this toxin works, we actually kind of have to understand the target of this toxin. It's a neurotoxin, right? It attacks the nervous systems of vertebrates. But to really understand that, we kind of need to take a second and break down how the nervous system works in the first place. So your nervous system is basically a network of specialized cells that run through your body almost like wiring. And they work kind of like wiring. They send electrical signals that regulate your ability to sense things, your ability to control your muscles, and basically it's the circuitry that runs your brain. But how this signaling actually works is sort of through chemicals. The nerve cell basically releases little tiny chemicals called neurotransmitters in this little gap between the end of one nerve cell and the start of another. And these little chemicals, these neurotransmitters, cause a signaling pathway that essentially catalyzes an electric charge to run through the nerve cell, which again at the end of the next nerve cell releases those same chemicals into the next gap or synapse between nerves. If you can interfere with the nerve's ability to send signals, you can disable a lot of different things. Many neurotoxins work by turning off the nerves and cause things like paralysis. But that's not what's happening in a widow bite. We're not paralyzed, well, we're kind of paralyzed with pain, but it's muscle spasms, it's horrific whole body aches. And the reason that works is alpha-latrotoxin is essentially locking your nerves in the on position. So we can call the phase where it's firing that electrical signal and releasing neurotransmitters on. Generally speaking, there are lots of little charged atoms in the fluid your nerves are surrounded by, and your nerves need to slowly absorb those charged ions to build up enough charge to fire. But if you can add more pores that these ions can get in through, you can actually turn nerves on faster or keep them on and keep them in this firing mode. And if you can do that to pain receptors, you can cause something to be in a lot of pain for a long time. It turns out what happens is alpha-latrotoxin basically burrows into the cell membrane of a nerve cell and creates its own calcium channel, allowing a lot more calcium to flow in than would happen under normal circumstances. This causes your nerves to basically overfire. And that's why we get those muscle spasms, that pain. Your nervous system is basically being short-circuited by the venom. And this effect is kind of proportional to how many pores have been added to your nerves. So that's basically a complicated way of saying it's proportional to how much venom is in your system. When I was bitten by the red widow, I got a very small pinch and release bite. I did not receive a lot of venom from that spider. So my symptoms were fairly mild. Localized aches that didn't really exceed a 4 of 10, and it only lasted for about 12 hours. Some people report systemic symptoms where their whole body is in agonizing pain for sometimes anywhere from 72 hours to a full week. Like, widows don't usually kill people, but when you're bitten, you sure wish you were dead. In some cases, like the red widow in particular, and also there's reports of this happening with Australian redback spiders, full tanks of venom can also cause permanent symptoms that occur perpetually for the rest of the victim's life. We're not exactly sure the mechanism behind that, but we would have to imagine it's something to do with the amount of venom and the amount of pores that latrotoxin is able to produce in the victim's nervous system. Like I was saying earlier, their venom is insane, but the chemical insanity of widows doesn't stop with their venom either. There's this quote that's been circulated on the internet that spiderwebs are stronger than steel. And it turns out that many spiderwebs, and especially widow spiders, actually do have a stronger tensile strength than steel, which is classically thought of as one of the strongest metals ever. That tensile strength basically means it can withstand stronger pulling forces. Proportional to its weight, it can withstand more of a pulling force than the same amount of steel could, which is pretty impressive for a tiny little spider. And the reason this works actually boils down to the chemical structure of web, and it's kind of insane. So it basically looks like this kind of net of little tiny strings and these little crystal blocks. of amino acids, basically protein building blocks that are packed so tightly and in such an organized structure, they resemble real-life crystals. These crystals are extremely hard and extremely tough, and they act as anchors for those many strings to attach to, almost like a little brick of Lego with little Lego strings kind of woven together like a web within a web. And there's just repeating series of these throughout the entire strand of silk. The crystals give it a strong structure, and those little mini strings give it elasticity, so it can kind of stretch and bend and move all over as much as the spider needs it to. But one of these strands, which has a network of these little blocks and mini strings, is not one strand of silk. One strand of silk has many of these bundled together. It's an array of fibers that all work together to give the silk its support. Kind of like how a rope can pull the weight of a giant boat or ship, but like the single fibers built into that rope would break really easily. When they're all combined together, it increases the total tensile strength of the material. Now what's crazy is, not only is it stronger than steel, it's actually tougher than both steel and Kevlar. Yeah, like bulletproof vest Kevlar. But that can be kind of misleading wording. Stronger refers to its tensile strength, like how much you can pull on it before it breaks. Toughness refers to its durability, its elasticity. So kind of like a rubber band, it can expand and contract without actually deforming. Spider silk can absorb much more energy than steel or Kevlar before it actually deforms and warps. So usually we don't see compounds that have both high strength and high toughness. Usually it's one or the other. So it's kind of interesting that spider webs have been able to sort of optimize for both. And it's this insane chemical power, both on the toxic venom front and the chemistry of web front, that has made these things super effective, even in some really bizarre and remote habitats. Widows have been so successful that not only are there dozens of species, there are even some really rare and obscure species that have conquered some of the most unique habitats on Earth. We mentioned the red widow earlier, which lives a bizarre, almost orb weaver lifestyle in Florida scrub habitats, catching flying insects instead of hunting along the ground. But it gets even weirder than this. In the Tatacoa Desert of Western Colombia, there is a desert endemic widow, and it's so obscure it was only described in 2021. Like, this thing was discovered recently and pretty much nobody talked about it. Its scientific name is Latrodectus garbe, and with how recently it was discovered, we don't know a ton about it. But given the arid habitats it calls home, near the equator where it's both arid and very hot, resources are going to be scarce, which tends to result in much more toxic venoms. So we could be looking at one of the more venomous species of widow spiders here. In those same deserts, it is found alongside a few species of six-eyed sand spider, which are also among the most dangerous of the Sicariidae spiders. So we're talking a very extreme habitat and a potentially very extreme spider. On the other side of the world, in the harsh deserts of the Middle East, you have Latrodectus revivensis, which aren't exactly uncommon in the habitats they live in, but it's uncommon that people are ever in the same area that these spiders are. We're talking some of the harshest climates on Earth. Like, people just don't survive out there. So there's not really been a reason for humans to ever interact with these things. And they're weird because they're also living in shrubs and low-lying plants instead of the rock crevices that we normally associate widows with. So it's kind of living that like fly-through zone, red widow sort of ecology, rather than typical, crevice hiding ecology, which makes it a particularly unusual widow. You have the Finda button spider, found in a very niche habitat in the southern regions of Africa. These rare sand forests that are actually an endangered type of habitat. So this is potentially an endangered species of widow. And of course, there's the Galapagos endemic widow spider, which we don't think is all that special biologically, but the fact that it's from the archipelago that has all these unique endemic species does make it particularly interesting. But of course, we also have the most legendary widow of them all, the white widow. It's one of my personal favorites because it really breaks the mold of what it means to be a black widow. I mean, look at this thing. It looks nothing like any other black widow until you see that hourglass mark. And even the hourglass hourglass mark. It doesn't look like the hourglass marks of other widows. It's a very, very unique spider. These are found in the steppe habitat of Central Asia and North Africa. These semi-arid, treeless grasslands that have scorching hot summers and also cold winters. So these spiders are so extreme, they can literally handle all of the extreme elements that occur in that steppe environment. Naturally, food is very scarce in these habitats. They're not quite as bad as full deserts, but they're not great, which might hint at a more toxic venom, but their bite is very poorly understood. They're thought to be less toxic than the Mediterranean black widow, but people aren't really encountering these things, and as far as I can tell, bite report data doesn't exist. So we have no idea how bad the white widow bite is, and I don't particularly want to test it out for myself, though of all the widows in the world, this is one that I certainly do want to see in person before I die at some point. I mean, it's insane. Before researching for this video, I didn't even know that there were 35 species. You probably didn't know there were 35 species of black widow in the world. And like, there's a part of me that wants to make it a mission to be the first person to film every single one of them in the wild. It would be kind of insane, kind of challenging, but could be interesting to see. Who knows? But it is one of those things where when we actually peel back the curtain and go deep into the worlds of these animals, the dangerous black widow becomes a whole vast world of so many more species and so many more biological secrets than we could have ever imagined. And this is not a unique feature to widow spiders or spiders at all. Another group of animals that are often feared by many people are snakes. And even here in the US, the diversity of snakes is actually insane, and I guarantee there are some really weird ones that you probably didn't even know existed. So if you liked going down the rabbit hole of widow spiders and you'd like to discover every single snake in the entire US, check out this video right here. Hope to see you there, but until next time, don't forget to get outside and find your own adventure.